Hello everyone, this is Deepak Kumar and welcome back to my channel. Today we are going to discuss question number 61, rotate list. In this question, we are given a list, a linked list, and we have to rotate an integer k, and we have to rotate it by k places toward right. So let's understand what the question says first. So let's take our linked list. Let's say this is going to be our linked list, and k is, let's say, 3. Then on first rotation, it will become 6, 1, 2, 3, 4, 5. On second rotation, it will become 5, 6, 1, 2, 3, 4. And on third rotation, it will become 4, 5, 6, 1, 2, 3. So, how we are going to do this? So, basically, my idea is to first calculate I, which will be number or size of my linked list. Then, what we will do now, then we will bring k less than equals to I so that we don't have to face any problem while rotation. Let's say, let's see what I am talking about. If my linked list is 1, 2, 3 and k is 4, then what I am going to do is to bring k in less than equals to I. Something like for first rotation, my linked list will be 3, 1, 2. Then at second rotation, it will become 2, 3, 1. Then at third rotation, it will become 1, 2, 3. Then at fourth rotation, it will again become 3, 1, 2. So we are going to use modulo to bring k less than or equals to I. It will be, I am going to use this formula. Let's see what this formula does for us. Let's say k was 3, I was 6. I'm talking about this case. Then for then what my k will be 6 minus 3% of 6, which will be 3. And how is it? Let's see. 6 minus 3, as remainder of 3 when divided by 6 is 3 itself. So let's see for any value other than 3. Let's say k equals 2 and I equals 7. Then what will be k? It will be 7 minus 2% of 7. It will be 5. What if k equals 0 at any I? Then k will be I itself. Actually, this thing will help in rotation at k equals 0, k equals to I, etc. Actually, this line of code will help us in rotation. In our basic approach, we will first calculate I, which is number or size of the linked list. Then we will transform k into the number, so how many elements we have to skip in the linked list before starting to add in our answer linked list, which we will have to return. In this case, it was 3. So in answer, we will first add 4, 5, 6. Then we will go to head. Then we will add the rest of the linked list element. So this was my basic approach. So let's start the question. Now we will first take out for some edge cases or some easy cases, like if my head is empty, then there is no need to go for all these headaches. We will just simply return our head. Now let's declare our list node temp. Now it will be used to traverse. We will use temp to traverse the list node head. Now let's calculate I. My while loop till my temp does not equal null pointer. We will increase the I and then move forward in temp. Now what we are going to do? We will directly use the formula first, and then another if condition. If my I equals k, then what we are going to do is to directly return head. Why is this so? If my k equals 5, then there is no need to change. It will be the same one. Now from here, our real code starts. We will declare j first. J will be used in the code to track the number of list nodes we have pushed so far, so that we don't lose the track of number of elements, as all elements as multiple elements can be in common. Now let's declare some list nodes which we will be using in our code. Now new list node. Now this will be using to store. Now we will start another while loop again here, while temp does not equal to null pointer. But before that, we will have to reassign temp as for head, as temp has already reached the limit or the last point. What here we are gonna do is to first check if k is my greater than 0. If yes, then we will decrease k, increase temp for the next pointer. This is gonna help to move forward. Like first one was for a1, then we have moved for second, then third. At 4, my k will be 0, and at that point we will use else. Here temp dot next will be my temp. Then we will move forward for temp, and for temp 2, here we will increase j. And one thing, if my temp reaches the null pointer, what we will have to do is to reassign temp to head. Why we are going to do this? Why we are doing this? Why we are doing this? This is basically when temp reaches the last element, we will have to go to the first one. And if my j equals I, which means the number of elements required are already in temp or in the result. So let's break. Now, now as you can see, we are assigning the values of temp into temp. So in the last position of temp or our result, it contains the like in here, it contains 3, but the temp had the address of 4, which is already here. But but we have no requirement of that. So we are going to assign null pointer there. And now let's return the head of our solution, which will be result.next. But why not dot next? For that answer, we will have to move here. Here we have used a dummy node which had the value of 0. That was not in the uh, that was not in the list itself. Maybe it can be, but it is not necessary. So we are going to exclude that one. So now let's test the test cases sum. You can see all the test cases given by the LeetCode have been cleared. So let's try some of our own. First, we will go for all, then for none, then just a single one, then single one with multiple. Actually, these are the sum of the test cases which I found as an edge cases while solving this question. So let's try these. As you can see, all the test cases have been cleared. So let's try submitting the question. Now, as you can see, all the test cases given have been cleared. So now you know our approach, the intuition, and how we solve. If you like our approach, then please like the video, subscribe the channel, and comment your thoughts. For more such videos, please follow us. Thank you.